Yesterday we formulated a differential equation for this physical problem. The corresponding differential equation is dx1 by dt is equal to minus 2 by 21 x1 plus 1 by 50 x2. dx2 by dt is equal to 2 by 25 x1 minus 2 by 25 x2. x1 of 0. x1 of 0 is equal to 25. x2 of 0 is equal to 0. x1 of 0 means the unit this one. Initially, let us suppose that the sake of discussion, the tank contains 50 liters of water in which 25 kgs of salt is dissolved. Our assumption is x1, x2. We wish to construct mathematical model that describes the number of kgs x1t, x2t of salt in tank A and tank B. Initially, 25 kgs of salt is there, so x1 of 0 is 25. Initially, the tank B contains 50 liters of pure water, so x2 of 0 is 0. These are the initial conditions. Now we have to enter this system in M file. Now take the same file. Okay. Fx f1 of 0. f1 of 0 is equal to minus 2 by 25 plus 1 by 50. 1 by 50 x2. Second differential equation is 2 by 25 x1 minus 2 by 25 x2. Save this one. Okay. Now we entered a differential system of differential equation in M5 B422. The file name is B422. Now we go to command window OD45 B422 T span 0, 50 liter. 50 minutes and taking. What are the initial conditions? x1 of 0 is 25, x2 of 0 is x2 of 0 is 0. Now, what is t comma x? X contains two variables, x1 and x2. Okay. You see this one, initially 25, the concentration is decreasing. Here the concentration is increasing. At certain time after 14 minutes, both the concentrations are same. Then start decreasing now. Increasing, again decreasing. Decreasing, it is also decreasing. Now if you see the plot, what we got? Plot t comma x. We get clear here. This is the status. Initially 25 kgs salt is there in tank A. Initially pure water is there in tank B. As time goes on, concentration of tank A is decreasing. The concentration of the tank A is increasing. And later it is again decreasing. Okay. So if we take a lesson, what is the tank? What is the tank A? Concentration of the salt in tank A. Concentration of salt in tank A. This is concentration of salt in tank B. So any doubts on this one? Any doubts on this topic? System of equations. Any doubts in this one? Any doubts on this one? Any doubts on solving system of equations? Any doubts on the system of equations? Solving system of equations? Participants? OD45 is solver. B422 is M5. B444 is the file name. That file is containing different system of differential equations. Okay. Any doubts? Might start. Any doubts? OD50, OD45 is OD45 is a solver based on Rangakutta method. There is no OD50. So OD45 is a file name. I hope this is the first class for you. I think they're absent. OD45 is solver, just like a square root of SQRT. Yes, like sine function, so like sine cos function, tan function. So I am using ODE 45 of bracket, you see this. Here I am using ODE 45 of like this. This is a function. It is a function. ODE 45 is one function. It solves the differential equation. Like ODE 45, there are some solvers are available in MATLAB. First class itself I told. ODE 45 based on Rangakutta method. It is not ODE 4550. It is just like ODE 45, ODE 23 based on Rangakutta Tada. ODE 113 is based on Adams Dashboard method. ODE 15 is based on NDF method algorithm. Okay, just like an algorithm. It is a BOD. They named as a BOD 45. Yesterday, I created one M5 to uh, solve a differential equation using based on then you put a fourth order method. I named as B4 double two name. Like that, they named as a ODE 45. That is ODE 45 is a solver to solve ordinary differential equation. Any doubts? Next. Shall I take second order differential equations? Shall I take second order differential equation? So suppose just I'm taking second order first. So suppose if you want to solve a second order differential equation, we convert the second order differential equation to system of differential equation and we solve the second order differential equation. For example, I'm taking in general I'm taking our second order differential equation. Okay. So for example, I'm taking y double dash. General I'm writing one y double dash plus y dash plus y is equal to 0. So any independent variable x or t or x d square y by dx square, whatever it may be. Y of 0, initial conditions, y of 0 is equal to y of 0 is equal to y of 0 is equal to 0, y dash 0 is equal to 0. Y dash 0 is equal to 0. Y dash 0 is not 0. You take both is not good, 1 you take. Okay. Now how to convert how to solve this equation? So now there is a standard substitution is there. Am I correct on that? So if you want to solve second order if you want to convert second order differential equation to system of differential equation, we take a substitution like this. X is equal to the known substitution x1 is equal to y, x2 is equal to y dash. X1 is equal to y, x2 is equal to y dash. This is the standard substitution. If it is third order differential equation, we introduce one more variable. X3 is equal to y double dash. If it is a fourth order differential equation, we introduce one more variable like this. Now I have taken second order differential equation, so it's not necessary for me. Okay, my equation is second order differential equation. So the substitution is x1 is equal to y, x2 is equal to y dash. I need y value. That means after solving the system of differential equation, I need x1, not x2. x2 is the solution of x2 is the y dash. Okay. Suppose x1 is equal to y. What is x2 dash now? What is x2 dash? Or x1 dash, sorry, not x2 dash, but x1 dash. x1 dash. What is x1 dash? Y dash. What is y dash value? x2. Is it clear for you? This is x2. x1 is equal to y. I am taking x1 dash. x1 dash is y dash. Y dash is nothing but x2. x1 dash is x2. This is one equation. What about this y double dash now? You substitute all these values in this one. Now I am writing this y double dash. Y double dash is equal to, after that, we have to rewrite the given equation. Minus y dash minus y. Am I correct or not? From this equation, from the given equation. What is y double dash? Y double dash is nothing but x2 dash. What is y? Y is nothing but x1. What is y dash? x2. What is y? x1. So x2 dash, x1 dash is x2, x2 dash is minus x1 x2 or x2 x1, whatever. x1 x2 x1 x2 minus x1. This second order differential equation is equal to this first order system of equations. Now y of 0. What is y of 0? Y of 0 is equal to x1 of 0. x1 of 0 is equal to 0. Y of 0 is equal to x1 of 0, x. Y of 0 is 0, so x1 of 0 is 0. Okay. Next, y dash 0 is equal to x2 of 0. x2 of 0. Y dash 0 is equal to 1. Y of 0 is equal to x2 of 0. Y dash 0 is 1. So x2 of 0 is 1. The given system, this given system, given second order differential equation is equivalent to system of equations. System of equation is the initial conditions. Now we solve the system and we take only x1, not x2. x1 is my solution. x1 is y. I need y value to satisfy the given equation. So x2 is nothing but x1 is nothing but y. We solve the system and from that we take x1 value. Okay. Now we have to take it. We have to write num file. Not necessary this one. Oh, sorry. I have to take num file here. Oh. Now I have to write the system. Okay. Here it is there. From this we can find, we can write. Here it is there. From this we can write. B4 tx. Okay. This I am removing. Delete. What is the first one? What is the first one? F of 1 is equal to this one. X1 dash is equal to x1 dash is y, x1 dash is y dash is equal to x2. That is x of 2. F2, f of 2. Second equation. F2 is nothing but minus x1 of 1, x1 here, x1, x2 minus x1 star x2 minus x1 x of 1. Okay. And both the equations. Minus x1 x2 minus x2 minus x1 minus x1 x2 minus x1. Okay. Now you save this equation. Minimize. Now t comma x. T comma x is equal to ODU 45 before double 2 finally. So initial 0 to some 5 or some 0 to 5 or 0 to some certain interval 0 to 6 whatever. What are the initial conditions? Initial conditions I forgot. Initial conditions 0 and 1. 0 semicolon 1. Okay. Now solution. What is the solution? So don't worry, you can use if you remove the semicolon, what will happen? T and x will be t comma x will come. It's not a problem. Okay. T value will come. First T value will come. Next x value will come. So I want to write side by side. That's why I'm writing. I'm giving semicolon there, and the later I'm writing t comma x. So t and x will come side by side. Okay. That is it. Nothing is there. So t is equal to 0, x1 is 0, x2 is 1. According to our initial condition. As time goes on, like it is going like this. Now, what is my solution actually? My solution is what is my solution? T comma. Now, what is my solution? T comma x contains two values. Am I correct or not? X contains two values. I need only all row elements of the first column. That is my solution. Am I correct or not? This is my solution. In this one, this is x1, this is x2. x1 is my solution. That is y. x2 is y dash. x2 is y dash. So, T, all row elements of the first column. First column of x. X contains two columns. Okay. Now, if you want to plot T comma x of all row elements of first column. I'm plotting. This is the plot of solution plot. Suppose if you want to plot both x1, x2. The x1, x2 means x is our solution. x1. First value, this is y value. This is y dash value. Okay. Any doubts on this second order differential equation? Any doubts? If you don't have doubts, I will go to next topic. Any doubts, sir? Any doubts? Participants? Suppose if you want to solve third order differential equation, we introduce three variables. X1 is equal to x1, x2, x3. X1 is equal to y, x2 is equal to y dash, x3 is equal to y double dash. Like that. Okay. So if you have any doubts, you can ask. Otherwise, I will take another topic. This is about differential equation. This is the way of this is a method to solve a differential equation. Two things I explained here. I explained. I wrote a program, and as well as I solved the differential equation using solvers also. Okay. Now with this, I'm closing this differential equation. Now I'm taking another topic, that is the solution of system of nonlinear equations. Nonlinear equations. Nonlinear equations. So nonlinear, I mentioned nonlinear equation. We can transcendental. All will come. Nonlinear equation means nonlinear, transcendental, everything. So already we uh, uh, we have written one program, bisection method, secant method to solve nonlinear equations. Am I correct on that? And there is inbuilt functions. The advantage of inbuilt function is we can see the iteration and everything. Okay, like just like ODE 45, the F0 is a solver. F0 is a solver to solve nonlinear equation with a single variable. Single variable nonlinear equation. Okay. The command F0 gives root of a single variable nonlinear equation. I mentioned nonlinear equation. This nonlinear means here the transcendental also. Okay. Transcendental equation. What is this fun? What is this fun? Fun is nothing but a function. Here also same. We have to create one M file. We have to write that nonlinear equation in one M file. Okay, in one M file. Nonlinear equation in one M file. That function we have to call, that M file we have to call here. Just like ODE 45. Just like ODE 45. Okay. So x is equal to x is equal to f0. F0. Fun x naught tries to find the zero of a function fun near x naught. If x naught is a scalar. So the second thing I will explain is we cannot understand now. Okay. So if a function is, for example, these options are also I am not touching. For example, if I want to solve this equation, find the root of the equation x e power x minus cos x is equal to 0. X e power x minus cos x is equal to 0. It is a nonlinear transcendental equation. Am I correct? Nonlinear and transcendental equation. Find the root of the equation x e power x minus cos x is equal to 0. This type of equation we can solve using bisection method also. Am I correct on that? Bisection method. We can write our own program, bisection method, or we can take secant method, Newton-Raphson method. So we can write a program. So, but there are inbuilt functions are there to solve this type of equations. Here we have to write this equation in one M file. In one M file. After that, and we have to save in the file name. Root one is here. Root one is the file name. Save root one name as in MATLAB part. We can find the root of the given equation near 3 by giving. So why I am taking 3, I will tell you later. 3 by x is equal to f0 of root 1. Root 1 is a file name and 3 initial value. Okay. Sometimes we will mention the interval. Everything I will one by one I will explain. So my equation is in x e power x minus cos x is equal to 0. That is my function. Now that is only I am concentrating. I am creating M file, one M file. The same M file I am taking. Okay. What is the variable here? Only x, not t. There is no two variable, only single variable. X is there. What is the x? F is nothing but my equation is output is f. Output is f equation. If you run this program, it takes f value. F is output. What is x star? exp of x minus cos x. Say we should not run this program. Say B422 contains B422 contains one equation that x e power x minus cos x. What is the B422 of 0? B422 of 0. That's minus 1. If you substitute x is equal to 0 in this equation, cos 0 1, x is equal to 0. This entire value 0 minus 1 minus 1, that is output. Output is displayed with minus 1. B422 of 1, what is the value? 22 of 1, 2.1780. 2.1780. To get 2, what is the value? 15.1943. At 3, 61.2466. Okay, these are the function values. Suppose at 1, minus 1, what is the function value? Minus 0.9082. Minus 0.1455. So here minus 1 is negative, minus 2 is positive. So one root is lies between these minus 1 and minus 2. Am I correct or not? Minus 1 and minus 2, there is one root. Will you accept or not? There is one root between minus 1 and minus 2. Similarly, there is one root between 0 and 1. At x is equal to 0, minus 1. At x is equal to 1, it is positive. There is one root lies in between 0 and 1. And also there is another root between minus 1 and minus 2. What happened to b of by the minus 3? It's positive, it is increasing. Minus 3, minus 4. Again, you see the minus 5. So minus 3 and minus 5, there is one root. I'll take minus 4, what will happen? I'm taking minus 4. Positive. So here minus b at x is equal to minus 3, the function value 0.8406. At x is equal to minus 4, oh, again positive 1. This is also positive. Positive. This is positive, this is positive. This is negative. Oh, sorry, okay. This is negative. So root is lies between minus 4, minus 5 and minus 4. Root is lies between minus 5 and minus 4. So if you take any constant in the equation, it has at least one root most of the time. If it is a continuous function, so it has at least one root. So this function has a root in between 0 and 1, 0 and 1. -1 and -2, -4 and -1, -4 and -1. So in that case, initial value plays vital role. You have to mention the initial value. You have to start somewhere. Okay. So here, there is the importance of the initial value. See, in numerical methods, initial value is very important. In bisection method also, we are choosing two values, a comma b, in such a way that f of a and f of b are opposite sides. Here also, we have to choose one value. That's why I started with 3. I started with 3. We have a root value 0.5178. I told that the root is lies between 0 and 1. Am I correct? No. Here 0 and 1. Here you see this one. The root is lies between 1. Root is lies between 0 and 1. 0 f of 0. Function value at x is equal to 0 is -1. The function value at x is equal to 1 is positive. There is one root in between 0 and 1. MATLAB find the root and displayed 0.5178. Suppose if you take initial value as for example -1 or minus something, it will find root value nearer to that value. Okay, that is it. Now so many things are there up to this. So many things are there here to explain. One by one I will do. Okay. Okay. See and see. Now, what is the value? Root is equal to x is equal to f0. What is my function? b4 double 2. Starting point is 3. For example, I am taking starting point as 3. 0.5178. What is the function value at this point? b4 at x. At x is nothing but that is minus 3.3307 into 10 to the power of minus 16. That means 0.00. That is 33307 minus. This is a function value and this one. That we can obtain by giving like this also. There is a command here. X comma f value, function value. We get. I told you, no, this is the root. The root value, the function value at this root is minus 3.3307 into 10 to the power of minus 16. Not only 3. Suppose if you want to, you can mention this root also, root interval. If you the interval 0 to 3, like this also. 0 to 3. The same way. So we can give 0 to 1 also. I want to find out the rate in between 0 to 1. Same way. Suppose if you change the root is lies between some values there, no? -4, -5. -5, -4. There is one root. Am I correct or not? There is a root in between -5 and -4. F of -4 is negative. F of -4 is positive. So root is minus 4.6686. At this point, the function value is this one. Here we can take -4 also. We will get the same value. -5. The root nearer to this point is this one. The function value at this point. Function value at this point is this one. Almost it is 0. Okay. This is about F0. F0. There are options. This is the most interesting thing is here. I'm coming to next point. Options. Then I will come to the first slide. And then I will go to the first slide. This part. This part I will explain. To take options, then we will get a clear area. Well, we can see the iterations also. What are these parameters? Options. Here, this is the option. Just I am copying this one. Optim set display iterations. We can see the iterations also. Okay. Control C. I'm taking the Control C. Let's copy that. Control C. I want to display the iterations. I want to see the iterations of this F solve F0. X is equal to F0 before double two initial value 3. I'm taking initial value as 3. First options we have to define. No? Control. These are the options. I'm not taking F value by because initial value I want to take 3. Then I will take minus 5 other value. Options. Options. If you take these options, you get this. It's gonna value. Like that. What happened to this one?
Op- Sir, options is not under single quotation.
Oh, oh, quotes. 100 in quotes. This is the thing. 100 in quotes. That is the thing. What MATLAB is doing here? I give an initial value. I give an initial value. How the MATLAB is doing all these things? How MATLAB is identifying the root? This is a very interesting thing. Here, what MATLAB, I have given a function f of x like this. Some x e power x. What let MATLAB do? Initial value is 3. I have taken a is equal to 3. It takes 3. A is equal to 3. B is also 3. A is equal to 3. It writes the function value. What is this function value? Next, what MATLAB do? This is A. This is B. Function value at A. This value. F of A. Function value at B. Both are the same. Both are same now. Remember. Now it takes some delta neighborhood of A minus delta into A minus delta comma A plus delta. That means it calculates 3 minus delta. It chooses arbitrarily some delta value. It takes one interval 3 minus delta and 3 plus delta. So at this point it calculates the function value. It is 3 minus delta. Some delta is a small value. It chooses arbitrarily. It chooses some value depending upon the problem. Most of the times it takes a fixed value. So 3 minus delta. 3 minus delta it means less than 3. It calculates for function value. And 3 plus delta it calculates function value. If both are, if sine of f of e is opposite to sine of f of b, stops the process. Otherwise, if both are the same values, it takes 3 minus 2 delta, 3 plus 2 delta. This process will continue until f of a into f of b are in opposite sign. That is the thing it is doing here. 3, 3, the function value is same. It has taken some delta, 3 minus delta and 3 plus delta. The function value again positive and positive. 3 minus 2 delta, 3 plus 2 delta, the function values are positive. It is going, it is came up to minus 0.28471. At this point, the function value is negative. At this point, the function value is positive. So it stopped the change. So he found one interval. So root is there in between these two values. Again, it is based on intermediate value theorem. If f of a and f of b are an opposite sign, the root is lies between. We can there exists at least one root in the open interval of a comma b. Am I correct? Now it has chosen one algorithm. We don't know which algorithm interpolation procedure they mentioned as interpolation. So we don't know the algorithm. Based on fixed algorithm, it find the root. Okay. So 0.517757 is the root. And the function value at this point is this one. Okay. So 0.5178 up to 4 decimals it is displaying the function value is this one. Okay. So for example, what will happen if you give a root for a list of point? Suppose if you give like this list of these three interval, if you root to 3, for example, what will happen? I mentioned the interval. So if I mention the interval means f of a is f of a and f of b are opposite sign. It calculated the function directly. It start the iteration procedure. Function value at 0 is minus 1. It started x of 0. It started the iteration procedure, and it finds the root. Okay. So this procedure is not necessary. Here, if we give initial value, it tries to find one closed interval in such a way that f of a is f of a and f of b are opposite sign. So if you mention interval, if you mention an closed interval, so directly it start the root value. Okay. This is the options. This is about options. There is another options. There is another options. So we can see the we can see. Now this I am going to first slide. First slide. What is the first slide? It first tries to find an interval containing x naught where the function values of the interval endpoints differ in sign. Then searches that interval for a 0. It first find an interval containing x naught, containing this x naught value, where the function values of the interval endpoints differ in sign. Then searches that interval for a 0. Okay, that is the procedure. That is the procedure. Okay. Okay, now there is another options. There is another set of options. We can see the iterations and as well as we can see the plot of the interval. I'm copying this control C. Control V. Same options. We can see the iterations. F of 0 is minus 1. I have taken this one values. I have taken interval. Directly it's starting from x is equal to 0, x is equal to 0 minus 1. X is equal to 1 some value, x is equal to 2 this value, x is equal to 3 this value, x is equal to 4 this value. This is 0. I need a value nearer to the function value should be 0. Correct? Fine. After 10 iterations, it is almost equal to 0. The function value is minus 1.1102 into 10 to the power of minus 16. This is the plot value of the iteration, that is function value. Current point x value, that is 0.575178. 0.5178. 0.5178. So any doubts on this one? Any doubts on this? Any doubts on this procedure? Any doubts? If you have any doubts, you can ask. Otherwise, if you want another problem, I will solve. It's not a big issue. If you want to, shall I solve one more problem or no need?
One more problem, sir.
No problem. Okay. X log x. I want to solve this equation. So I'm going to enter this equation. X log 10 of x minus, save this, b4 of double 2. So b4 of double 2 of 1. What is the value? Log 1 0. So minus 1.2. Negative 3. Positive. So root is lies between 2 and 3. Root is lies between 2 and 3. Root 4. Positive. It is increasing. Increasing. 6 is increasing. So root is lies between 1 and 2. Am I correct? 1 and 2 or 2 and 3? 2 and 3. Root is lies between 2 and 3. So like that we have to start. So now say x comma f value equal f0 of b4 double 2 at 4. I'm starting at 4. The root value is 2.7406. 2.7406. The function value is minus 2.2204 into 10 to the power minus 16. Suppose if you take an option, this one, these options. Options. So at 4 it is positive, at 4 is positive, it is reducing, it is increasing. So at root is like 2.72 into 2.72 comma 4.9051. Okay. So it is up to it obtained the root, it is interval contains a root value. Okay. After 5 iterations, it found the root, that is 2.7406. The function value at this point is this value. Like this value. Suppose if we take another options, it's another set of options. Another set of options. This is the thing. Okay. So 2.7406. This is the current function value. Nothing is there here. This is the iteration values. Okay. With this, today I am closing. Tomorrow I will take a system of nonlinear equations. System of nonlinear equations. Okay. So any doubts? If you have any doubts, you can ask.
No, sir.